All right, so let's take a look at the last concept, the last idea, the last thing that we have to cover in section 4.4, and that is the second derivative test. What the second derivative test is an alternate way to determine maximums and minimums, relative maximum minimums, using the second derivative instead of using the first derivative. Right? All right, so let's read what the second derivative test requires. It starts out by saying, let f be a function such that f prime of c is equal to 0, and the second derivative exists on an interval containing c. So what does this tell me? Right? Well, this tells me that I have a function that has a horizontal tangent line at some value c, and that the second derivative exists on an interval containing c. That means that we can determine the concavity at that value c. And so if I have a function that has a horizontal tangent line and I can determine the concavity at that point c, then if that graph is concave upwards, that is, if the second derivative is greater than 0, then you're looking at a minimum at that point. And if that second derivative is less than 0, meaning it's concave downward, then you're looking at a maximum at that point. Now, I'm going to scroll back up here to a long time ago. In fact, a picture from part 1. This right here, right? There's going to be some point somewhere about here where that tangent line is horizontal. And this graph is concave downward. That f prime of c is going to be equal to 0, and we're looking at a maximum. So horizontal tangent, concave downward, maximum. Somewhere over here there's a point where that tangent line is horizontal, where f prime of c is equal to 0, and concave upward. Horizontal tangent line, concave upward, minimum. Right? So what are we saying again? Horizontal tangent line, concave downward, max. Horizontal tangent line, concave upward, minimum. Here's the language, the mathematics of that. Let f be a function such that f prime of c is equal to 0, has a horizontal tangent, and the concavity can be determined. If it's concave up, it's a minimum. If it's concave down, it's a maximum. Now, there is the possibility that the second derivative could also be equal to 0 at that same value c. So you could have a situation where the first derivative is 0 somewhere and the second derivative is 0 somewhere. If that happens, then the second derivative test fails. That means it doesn't tell you whether you have a max or a min or neither. It says it could be. You have to go back and use the first derivative test to figure it out. Okay? All right, so I would like to do an example here where we're going to find the relative extrema, that is, find those maxes and mins for this thing, and we're going to use the second derivative test rather than the first derivative test. Okay? The requirements that we're going to have to do is we're going to have to first find those values c, where the function has a horizontal tangent line, right, where f prime c is equal to 0, and then we're going to evaluate the second derivative at those values. Okay? So we're not going to find all the critical numbers. We're just going to find the critical numbers where the first derivative is equal to 0, and then we're going to evaluate the second derivative at those numbers. All right, since we're going to be working with first and second derivative, let's go ahead and get those first and second derivatives. The first derivative is going to be a negative 15x to the 4th plus 15x squared. The second derivative, f double prime of x, is going to be, let's see, 4 times 15 is 60, so negative 60 x cubed plus 30x. Okay? All right, the first thing that we need is we need to know when is the first derivative equal to 0. That is, when is f prime of x equal to 0. So negative 15 x to the 4th plus 15x squared is equal to 0. I'm going to factor out a negative 15x squared. That's going to leave me with an x squared minus 1. Okay? That's going to give me that x is 0. This is going to give me that x is equal to 1 or negative 1. So all of these values right here, 0, 1, -1, these are all potential candidates for extrema. Right? Now what we need to do is we need to evaluate each of those in that second derivative. That is, we need to find out what is f double prime of 0. Right? What is f double prime of 1, and what is f double prime of -1? Right? So f prime, I'm going to start at the bottom and work to the top for no reason other than because I can. F double prime of -1 is going to be -60 times -1 cubed plus 30 times -1. -1 cubed is a negative number, and negative number, -1. -1 times 60 is -60 minus 30, -90. Right? If the second derivative is negative and the first derivative is equal to 0, what does that mean? Negative, so this is concave down. It's concave down. That means we're looking at a maximum, a relative maximum, at the point when x is -1, and then what's going to be the y value there? Well, the only way to figure that out is to take this -1 all the way back to not f prime, not f double prime, but the original function f, and evaluate it. Right? So when I evaluate that function in with a value of -1, I'm going to get +3 and a -5, so a -2. And so we have a relative max. Let's see what's happening at 1. F of 1 is going to be, f double prime of 1 is going to be -60 times 1 cubed plus 30 times 1. That's going to be -30. Still negative, still concave down, so another maximum. And this maximum is going to be at the point 1, comma, and if I plug a 1 into the original function, that's going to give me a -3 and a +5, so that's going to be a +2. Right? And now we'll check and see what's happening. Remember, that's a max. Right? And let's see what's happening at 0. Okay, if I plug a 0 into the second derivative, I get 0. So a 0 in the second derivative gives me a 0. And what does that mean? It means that at x equals 0, the test fails. So 0 could be a max, it could be a min, or it could be nothing. And the only way to find out is to go back and use the first derivative test. All right? So to figure that one out, we got to go back and use the first derivative test. Now I'm going to cheat a little bit since this was really about finding the second derivative. It's really about this right here. Okay? I'm going to cheat and figure this one out by looking at the graph. So let's go look at the graph of -3x to the 5th plus 5x cubed. All right, so we'll switch over to Desmos, and there's our graph. Now you can see over there, there's our minimum that we found at -1, -2. There's our maximum, our relative max that we found at 1, 2. And there's where the first derivative was equal to 0 and the second derivative was equal to 0. And you'll see that that is neither a maximum nor is it a minimum. And that if we had done the first derivative test, we would see that to the left of 0, it was an increasing function, and to the right of 0, it was still an increasing function, which means it wouldn't be a max nor a min. It would just be a odd point on the graph where the first derivative is equal to 0 and the second derivative is equal to 0. Okay? So that means that this guy is a big fat nothing. It is neither a maximum nor a minimum. All right, another example, same thing. My job is to find extrema. Right? I'm going to run a little quicker on this one because I know what I'm doing a little bit here. F prime 5x to the 4th minus 20x cubed. F double prime, the second derivative, 20x cubed minus 60x squared. I need my candidate points. I need to know when the first derivative, that is f prime of x, is equal to 0. So when is 5x to the 4th minus 20x cubed equal to 0? We'll factor out 5x cubed. That'll leave me with an x minus 4 is equal to 0. So we get that x is equal to 0 or x is equal to 4. Now we'll test. We'll find out what is the value of the second derivative. When x is 0, that's also going to be 0. So do you see how we have the same issue? Okay. So this is a big fat I don't know. Now we'll check the other one. What is f of 4? I'm sorry, f double prime of 4. That is going to be 20 times 4 cubed minus 60 times 4 squared. 4 cubed is what? 4 times 4 is 16 times 4 again. I believe that's going to be what? 64 times 20. So 20 times 4 cubed is 1,280 minus 60 times 16, which is 960, which is greater than 0 because that's all that matters. And so let's see, how did that work again? First derivative equal to 0, second derivative positive, concave up, horizontal tangent line means we're looking at a relative min, right? And that relative min is going to be at the point 4 comma something. Now the way we find that something is we need to take 4 and put it back into the original function. So I need to find f of 4 to see what's happening there. So I need 4 to the 5th minus 5 times 4 to the 4th. Okay, that's going to be negative 4. Okay, little trick here for you. Rewrite the first term as 4 times 4 to the 4th minus 5 times 4 to the 4th. Factor, you've got 4 to the 4th times 4 minus 1. I'm sorry, 4 minus 5. Right. 4 minus 5, negative 1, so we have negative 1 times 4 to the, oh, I missed my exponent there, 4 to the 4th. And so whatever that is, let's see, 4 to the 4th is 16 squared, 256. So we get our negative 256. Right. So that doesn't look too bad. Oh, wait. We still have to go back and find out what's going on with 0. Right? Now, this right here is a great example of why I'm not a huge fan of the second derivative test. First derivative test never fails. It tells you whether you have a max or a min every single time. Second derivative test fails. And because it can fail, because it can cause issues where you have to go back, why not just use the first derivative test to begin with? All right, so let's go take a look at the graph of this one again, and we'll see what's going on here. All right, so we'll switch over to Desmos. There's the graph of this. Kind of a crummy scale, so let's bring this in until we can see more of it. So it looks like, well, maybe 0 is a maximum. And then there's our minimum at 4, negative 256. Right? Now, first derivative test would have gotten me that 0, 0 because to the left it's increasing, to the right it's decreasing, so up, down, max. And so we can go back over here and say that at 0, we have a maximum of 0, 0. All right, this brings us to the end of section 4.4. And I'll close it off there. See you all back here for section 4.5 next.